time for another DraftScience video presentation. So back to kinetic energy. There hasn't been any comments. So there's nothing to respond to. No counter argument to any of the arguments that have been made. So, yeah, I'll just attempt again to point out all the reasons why this is really bad science. It's totally unevidenced. There's nothing to argue because they don't have anything to put on the table. There's nothing on their evidence table. So there's nothing for me to counter argue. They just say it as if it's true. So they say force equals 1/2 mv squared, or energy or something equals this. And there's nothing that equals this. It's just made up. Alright, so they say, since kinetic energy increases with the square of the speed, an object doubling its speed has 4 times as much kinetic energy. So they say so. So there's no evidence demonstrating that this energy is ever collected or anything. There's any evidence that doubling the speed makes something 4 times more capable of moving stuff in the universe, that it has 4 times as much anything. For example, a car traveling twice as fast as another requires 4 times as much distance to stop. Again, this is what they made up. That distance, that is how fast you stop. Now, why do you stop? Let's just understand that when something's moving, Newton's law, it just keeps moving until something acts on it. So something has to take the energy away. So this is the key phrase, right? Assuming a constant braking force. So yes, if you have a constant braking force, it'll take 4 times the distance, but it'll only take twice the amount of time. So again, we're back to this argument. If it was raining and you have a bucket and you move the bucket sideways in the rain, you're not going to catch more rain. Distance is irrelevant. All that's going to matter is the rate that the rain is falling and that you have an opening that collects rain. So yes, of course, if you take the energy away, okay, from something moving twice as fast at the same rate, that is, you're pulling the energy out just as slowly, at the same speed, the same amount per unit of time, then it's going to take, then the thing has plenty of time to keep moving, because it's going to have twice as much time and it's going twice as fast. So yes, it'll go 4 times as far before it stops, but it'll only do that in twice the amount of time, which is perfectly consistent with what's really happening, is you're just pulling the energy out over time. So there's only twice as much energy because you're only extracting it for twice as much time. And you're extracting it at a constant rate. I mean, so these are people, again, they'll argue that you can trust them, that their stories about entanglement and superposition and all this stuff is rigorous and real, when they can't even do this. I mean, they have to use all this convoluted mush to defend something that's just plainly not true. Alright, so, and then it says after, assuming a constant braking force, again, which is a constant rain, a constant pulling of the energy out at a constant rate, of course the thing going twice as fast, it's going to take twice as much time to pull it out, but you're pulling it out at the same rate. And how far it goes doesn't matter, because again, how far it goes just has to do, distance isn't energy. Distance is the rate at which you're extracting energy, because theoretically everything goes the same distance. So, everything's traveling forever until you pull the energy out of it. I mean, it's just so obvious. But anyway, and so it says here, okay, as a consequence of this quadrupling, it takes 4 times the work. Now, this work is energy, so let's understand, you make work out of energy, so you could have used the word energy there, to double the speed. They have no experimental evidence. They can't show us a car that uses 4 times as much gas to go 60 miles an hour than it uses to go 30 miles an hour. They won't show us this experiment that demonstrates this to be a fact. Now, of course, you can use more gas if you try to make something go 60 miles an hour in the same amount of time that it took to make something go 30 miles an hour, because you'll waste a bunch of the gas spinning the tires. Okay, so you can force the experiment to match, but you can't do it in any kind of fair, reasonable way. So if you give yourself enough distance to get up to 60 miles an hour, or the same, or double the time, you'll just double the amount of gas you use. You won't quadruple it. So they have no experimental evidence. Again, we have nothing. We have no evidence that a 10-ton train going 5 miles an hour, okay, won't generate exactly as much electricity as a 5-ton train going 10 miles an hour. They won't show us any evidence of this ever being true. Nothing. Zero. They'll just reference. This page references Leibniz. Okay, and let's understand, they call it his approximation that it equaled mv squared. It was 100% wrong. I mean, Leibniz was arguing for a theory that was twice as much as the number they've decided is correct. So he was, it's the difference between saying 5 and 10. I mean, it's way off. It's not even, it's ridiculously off. 500 and 1,000. I mean, it's way off. And that's what it started with. And that's what was defended with clay experiments. And that's it. That's all they cite. Ambiguous clay experiments. They don't tell us what kind of clay, what kind of temperature, because somebody logical is going to know that, well, if I change the temperature of the clay, it's going to behave differently. Change the composition of the clay, it's going to behave differently. I'll get a different answer. So that's it. But that's all they got. And then they say this thing. 4 times the work to double the speed. Says who? And with what evidence? Right, it's really bad physics. So anyway, I'll read a little bit of Feynman now, just because, it's more of this convoluted nonsense. It's just gibberish. And then I'll point to the experiments that just, how can you deny the reality? Okay? I will request again, I really don't want to have to do these experiments. I'd rather somebody who does put things together and 3D print stuff and does all that kind of crap, loves to screw things together and do all that kind of crap and has the proper facilities to do some simple experiments. Just, make a little spring scale or buy one or whatever, have one. You might even have a little spring scale. Just see how much a stick of butter, okay, 102 grams, see how much it weighs when you drop it 1 meter. See how much it deflects the spring. Just so we can know exactly how much a joule weighs. Anyway, it's too simple. But anyway, there's a couple other experiments, which I'll go into in a moment. Alright, so here's a bit from one of the Feynman lectures that he actually gave as real lectures to a physics class. Okay, so I guess I'll do both of these paragraphs. Okay, in chapter 4 we saw that the law of conservation of energy is not valid unless we recognize that energy appears in different forms: electrical energy, mechanical energy, radiant energy, heat energies, and so on. So again, this is just, so he used a metaphor, a story, where he talks about a mother and a kid who hides the blocks, right? There's a certain number of blocks, and so this is about energy conservation. There's 20 blocks, let's say. But, and the mother goes into the room and there should be 20 blocks, but no, the kid has dropped some in the sink, or he's hidden some here, or they're over here. And this is just a way of saying that everything that's moving through the universe is interacting with other things, and by interacting with other things, they can be, pieces of their energy can be going in different places in the universe, but it's the same amount of energy in the universe. And that's basically the conservation principles that can be hidden. So if there is heat, it came from something. Things aren't hot just for the fun of it. They're hot because they're pushed together and they bang into each other because they have velocity and they can't lose their velocity. So, like in space, for example, when something gets hot, it doesn't necessarily radiate that heat because there's no atmosphere to pull, to take the heat away, to collect it as something interacts and leaves with more velocity, and therefore it's taken some of the velocity of the system away. So in space, you have to find some other way to get rid of your heat because the atmosphere is not going to do it for you, for example. All right, continuing. I'm just saying that this isn't that complicated a concept as you just kind of understand that the energy is constantly in the universe moving. So like a photon, for example, you can understand that the energy goes in and that maybe you'll see it as a reflection. Maybe the energy will just come back as a reflection. Or maybe you'll know it absorbs into the object and now the object gets hot because the energy could be going in any direction inside the object. But that heat will potentially find some other way to go to get out again. And then you can convert it into electricity, and you can change the path. The little piece of energy has a path in the universe. So if you could break the universe into these little tiny bits, you'd see that each one of the little bits has a vector and is going somewhere, but that vector will just be changed, and it'll continue to move through the universe for, I could just make the infinity symbol. It will keep moving through the universe forever. So every bit of movement we're made out of is movement that was moving dinosaurs, and it was, moving asteroids, and it was moving things. It has a history that is forever in terms of it traveling distance in the universe. Anyway, heat, and so on. In some of these cases, heat energy, for example, the energy might be said to be hidden. So again, they say that, but it's obvious that this is a truth, and they still won't even say it, that heat is just your momentum. It's just a form of your movement. So when two clay things hit each other and smash into each other, the energy isn't destroyed. The energy is heating the clay, both hunks of clay, and it's heating them in a direction. Primarily, one is getting hotter going that way, and one's getting hotter going that way. In the direction is still exists in the objects, except it's being spread, it's being scattered in those two directions. So as a whole, if you made a circle out of it, yes, it looks like it's radiating both ways because you have both sides and both ways of motion. But that's all it's doing. The energy that was going this way is now going some vector that was that way. The energy going this way is now going some vector that way, and it's just radiating like a sun would radiate it. And that's where the motion went. The motion went into moving little bits. The little bits are now going to radiate the energy in another form. So that should be something they all say, we got that one. Leibniz and Newton and everybody had already kind of figured that part out. They'd already had those discussions that when things appear to stop moving, they didn't really stop moving. It's just that they changed the way they're moving. And instead of the big bit moving, the little bits are now moving. The jelly beans inside the jar are moving. I don't know how to, But that's an old idea, and it should be kind of a written in stone idea. And if they paid any attention to it, there's no mystery here. So when something is getting hot, it's obviously absorbed some energy from somewhere. Something else had to move to give it the heat. All right, anyway. In some cases, the heat energy, for example, might be said to be hidden. This example might suggest the question, why are there also hidden forms of momentum? So again, it's just so silly. You're talking about just mv. All there is mass and velocity, and you're just saying that you're going to square the velocity, and that's going to be the big difference. Put a half in front of it, but it's still just those two components. So you can't change the two components you're making momentum out of, or you're making energy out of. Whether you believe in energy or momentum, it's still just the amount of velocity and an amount of mass. You're saying energy is a square thing, but it's still the same amount to start with that you're squaring, so it's still the same amount of velocity. You can't you're not squaring the actual velocity. You're not saying the thing's going, the velocity squared. You're saying the energy is represented as the velocity squared. So you haven't changed the elemental thing. So momentum is exactly the same as kinetic energy. In a sense, it's made out of exactly the same amount of starting material. You're just saying that the starting material somehow magically popcorns into some kind of exponentially growing amount of energy. If I just increase the velocity, I'll get huge increases in my amount of stuff. I've made more stuff. I made a squared amount of extra stuff out of it. But it's the same kernel. So, of course, it would work the same way. All right, anyway, hidden forms of momentum. The answer is very hard to hide momentum for the following reason. So this is the paragraph that's just so silly. And it goes back to this, whether something's a vector quantity, or some kind of scalar quantity, like somehow it's a different thing. So because you put a half and a square on the same substance, that somehow you made it into a new thing that's completely different than the old thing, which was mass and velocity. And somehow mass and velocity doesn't have a direction when you put 1/2 and a square on it. So when you put a half and a square, you abolish the fact that it had a solid direction. When, of course, you didn't do any of that. We're saying when a car is going 30 miles an hour, we know it's going 30 miles an hour in a direction. It's not going 30 miles everywhere, every direction. It's not going everywhere. It's going one direction and only has energy in that one direction. If I stand over here, I won't feel any car energy because it's not going there. It doesn't have a vector there. And they're pretending that somehow it does. The kinetic energy is magically everywhere. When, of course, it's not everywhere. When the train's going down the track, it's obviously not going down any track or every track. It's going down a specific track, and it only has energy in the direction of that specific track. I mean, it's just so bad. Anyway, the random motion of atoms in of the body furnish a measure of heat energy. Okay, so again, and we know the random motion of the atoms isn't randomly generated. That motion all has a history. That every bit of the Earth's velocity around the sun has a history. Every push, every bit of its energy to go around the sun came from something. It didn't just magically appear. It doesn't just freely happen. It has to be pushed. It has to be hit. It has to encounter other things that have energy. Just like the thing in space can't radiate its heat. Now it can radiate it in the form of photons, but I just mean it can't radiate it in the sense that it can't dispose of it until it interacts with something. Okay. All right. The random motion of atoms of a body furnish a measure of heat energy if the squares of the velocity are summed. So if I have v and I square it, and now I sum those numbers, somehow I don't have any positive and negative directions. So they're all a positive direction. Now, even though you know, quite obviously, that some of the atoms are going this way and some of the atoms are going that way, and that you know, okay, that in that circumstance, you would consider that a cancellation of overall motion. That the overall body, if I eject, stuff going 30 miles an hour this way and I eject 30 miles that way, I don't go any miles. So if I make a gun that has a bullet goes this way and a bullet goes this way, the gun doesn't go anywhere. Kind of idea. So why does that all of a sudden change now when I don't square the velocity? So squaring the velocity just means if I had a 4 for the velocity, I squared it, and it's 16 now. So what? It's not 16 in any direction. It's not 16 that's always plus, because I've already decided one direction is minus and one direction is plus. They're opposites. That's what I'm going to do to momentum anyway. I'm just going to play a double standard. I'm going to say momentum is now fundamentally different when it's exactly the same components. Mass and velocity. Same exact components. Somehow momentum is completely different. It doesn't make any sense. So anyway, the sum will be a positive result. That's because they're saying every direction is positive. So they're just saying none of these directions are opposite each other and none of them cancel. So when it's kinetic energy, the atoms somehow don't cancel their direction. So something pulls this way and something pushes, pulls that way, and somehow those two actions don't end up creating a neutral effect on velocity or motion. When of course we know that's exactly what happens. All right, the sum will be a positive result having no directional character. So it's completely an irrational statement in the sense that we know that atoms have directional character, that they're not moving in every direction, they're moving in specific directions. And if they weren't moving in specific directions, we couldn't sum their pressure, we couldn't do any of that stuff. They couldn't have equal pressure in a vessel, or they couldn't do any of that stuff if they weren't going in exactly opposite directions. All right, anyway. No directional character. So again, they just made this up, this idea that somehow energy doesn't have direction. When, of course it does. Every single bit of it does. It always does. All right. The heat is there, whether or not the body moves as a whole. So again, he's arguing that somehow its motion isn't completely dependent on how many atoms are going this way versus how many atoms are going that way. And of course, just like momentum, if there's more atoms going one way, then the thing's going to move that way. No different. All right, anyway. And conservation of energy in the form of heat is not obvious, is not very obvious. So again, of course, heat's not obvious because it's not going in the same direction. It's a scattering of the energy essentially, and it has canceling motions. You send something going that way and you send something going that way, and those two effects, those two pushes, cancel each other, and you end up with nothing as a push. All right, on the other hand, if one sums the velocities, so now he's saying the velocities do have some kind of character, they're going in a direction. And so now when I sum them, I'm going to say this is a positive one, and I'm going to say that's a negative one. So even though it's doing exactly the same thing as an atom, the atom is doing the same thing, has the same velocity, same mass, and has exactly the same motion and direction, they're saying that somehow now when I do the addition for momentum, I'm going to use plus and minuses. And I won't use plus and minuses when I do energy, which doesn't make any sense. I mean, it's, like I said, how can you trust people that are playing this kind of word game? I mean, this is just a word game. This is just playing games with things to arbitrarily say, momentum, I'm going to have this weird standard where I do plus and minuses, and then energy, I'm going to pretend it's not going in a direction. The velocity isn't in a direction. Of course it is. Of course the same rules apply, plus and minus. Anyway. On the other hand, if I sum the velocities which have direction, so again, it's just moronic, right? We already know the velocities have direction in both circumstances. Squaring the velocity does not change the fact that it has a direction, okay? Playing this game, saying the car has this much energy, doesn't change, kinetic energy, doesn't change the fact the car's moving in a direction is exactly the same. How come all of a sudden direction doesn't matter when you're playing your little kinetic energy game? Anyway, I'm sorry. I mean, if you can't admit that this is playing a word game, then yeah, you're just such a dishonest, scummy person. I'm sorry, you're just a scum. If you can't admit that this is strangling reality to force it to fit into the box they want to fit it into. They are forcing it to fit their theory. I mean, this is just such a grotesque effort. It's such obvious propaganda. I mean, you might as well, painting horns on Jews or something. This is ridiculously stupid. Okay, which have direction and find a result that is not zero. So now all of a sudden, okay, I'm going to count pluses and minuses, opposite directions for momentum, but I won't do that when I'm doing energy. Energy gets to be all pluses. But yeah, momentum, no, it's plus and minus. It's just obvious garbage. Okay, on the other hand, if one sums, zero, which means that the drift of the entire body in some particular direction. Okay, so if it's a non-zero answer, right, for all your, I did this, and I did this and this, added up all the pluses and minuses I arbitrarily created. And if I have something left over, it's going to move in that direction. Duh. Okay. Same would be true for kinetic energy. Same would be true if I have 3 cars going 30 miles an hour this way and only 2 cars going 30 miles an hour that way, and I tie rope between them. The 3 car is going to have more energy and it's going to push the 2 cars that way. Yeah. Kinetic energy, momentum, same outcome. Just too stupid. Anyway. By some particular direction, and such a gross momentum is readily observed. So again, yes, and it'd be exactly observed if you called it kinetic energy. The same result would happen. Calling it kinetic energy doesn't change the fact that you have 3 cars going this way and 2 cars going that way, and you'll end up with 1 car's worth of energy pulling all five cars. Only when it moves as a whole. Therefore, momentum as a mechanical quantity is difficult to hide. So he's, what sense does this make? If we call it momentum, it's quite obvious, that there's a bias in the system. But if I call it kinetic energy, I won't be able to see the bias. I won't see the 3 cars pull the 2 cars. Of course I will see it. I'll see exactly the same end result. Whether I call it kinetic energy or I call it momentum, I'm going to see exactly the same outcome. Nevertheless, momentum can be hidden in the electromagnetic field, for example. So again, it's not hidden in that field, it's stored in that field. I mean, that's what magnets do. They store energy. You push pressure in, and the pressure will be maintained until you release it, until you let it go. Field, for example. Let's see. In this case is another effect of relativity. So just absolute nonsense. Okay. So and so he says one of the propositions of Newton was that interactions at a distance are instantaneous. Newton didn't say that. So that's not true. Newton didn't know. He didn't know how fast light or gravity moved, and I don't think he ever made a statement declaring that it was instantaneous. He just had to assume it could be, or it wasn't. He didn't know. Anyway, all right. So I'll do a little bit of attempt again to illustrate how their own rules of relativity make this whole conversation ludicrous. The whole thing doesn't make any sense. So we had the example of you take the train that has 1 mass, and then you just drop another mass on it. Now this is an experiment I have shown. It's been done. There's no doubt about it. Okay, so now I change this to 2x, by dropping another weight on it that weighs 1 mass. So I can be going 10 miles an hour, 10 velocity here, and I'll go a 5 velocity here. Okay, and their argument is this object, the 2x thing, the thing that weighs twice as much going half as fast, has half as much energy. Okay, that somehow I lost energy. So this thing has 100, and let's just say the truth is that this adds up to 100 joules of energy, okay, when the car is going this velocity, but it's only going to be 50 joules of energy now after I dropped a weight on it. And their theory is that I lost 1/2 of the energy just by putting the weight on top of it, just by forcing this object to essentially push this object. That I somehow, by combining these two things, I somehow lost 50 joules, half the energy. Now, there's no experiment demonstrating that's what happens, and that somehow this object has more energy than this object. Okay, so I've been over that. All right, so related to that is the opposite scenario where you take something that weighs 2 masses, all right, and somehow you dispose of your half of that mass problem and gain energy from it. So in a sense, I can make a device that it's a 1 mass object, okay, and it's got a 2 mass object on top of it, okay, with a spring. So a 1 mass object. So it's got a 1 mass object. All right, and so I can just shoot the one mass object, this is a little air track up here. I can just release the spring, okay, and I can make this object just shoot off from the spring, and so what's going to be the implication? The spring has to be connected to this one mass object, right? So you get that part. That's what it's pushing against. So what's going to happen? We already know what's going to happen. This is going to leave at exactly the same speed as this. Okay, this is going to go 10 miles an hour, and this is going to go 10 miles an hour this way. All right, so that there shouldn't be any argument about that being the consequence. So if I make this a frictionless surface, no friction, and I use a spring, the spring is going to give as much energy to this as it's going to give to this. All right, and there's not going to be any difference in the energy. So all I have to do is this relativity stuff, right? And I say, well, what if this is already, the whole system is already moving 10 miles an hour? All right, so the whole thing is moving on wheels. Okay, so the whole experiment's moving 10 miles an hour. So then what I'm doing is I'm stopping this one's motion. So when the spring releases, this one's going to be going 0, right? And this one's going to be going 20 miles per hour. So it's going twice as fast. Now, didn't they just say to go twice as fast, I need 4 times as much energy? Well, where's the evidence of that? I'm going twice as fast, and I used exactly the same amount of energy I used to go 10 miles an hour. So their relativity argument defeats their own argument in the sense that physics always has to stay the same. You can't change the laws of physics. Well, you're clearly changing them, because now you're saying that if I'm in motion in the stagecoach or something, I've just doubled something's speed, literally. Now it was going 10 miles an hour, now this thing's going to be going 20 miles per hour, right? Because it shot that thing to 0. So it took the 10 miles an hour this had and gave it to this. I doubled its speed, and how the hell could you call it 4 times the energy? How could you say I used twice as much? I mean, that I used 4 times as much energy to get to this double speed. Can't make any sense. Just can't make any sense. I'm sorry, it doesn't make any sense for you to sit there and say I've now changed something. All right, so another way of doing this, right? So now we're going to get back to the uneven masses. So it just ends up getting, you have to be so careful how you say it, because it's easy to make a mistake. But yeah, I'd like to get, there is another argument to be made about the motion, and the fact that if I did make the object, I'm converting a 2-mass object into a 1-mass object with twice the speed, and that's the simple argument. So again, I'll just draw it a little bigger. So I have 1 mass, and then I slide another mass off of it. All right, and so I'm really just taking the energy out of this one, because it's going to have 0 velocity, and this one, okay, is now going to have 2 times the velocity. And so I'm repeating this, and I'm doing it in a way where you can't say, okay, well, this is the 2x, two mass. Which one of them has to leave is the 2-mass object. I guess that's what I've lost sight of. Okay, so this one has twice the mass, and it'll have half the velocity, right? And this one will have a whole velocity going that way. Okay, so because this one's twice as heavy, this one will leave with, so I'm just saying, so it's, where are you going to say that something was deformed? Where are you going to say that where you lost 1/2 the energy? Because you're going to say that the thing going this way has only half the amount of energy that the thing going this way has. This thing has twice as much energy as this thing. But how could it possibly have twice as much? I mean, the spring went this way, the spring went this way, it gave equal amounts of energy to both sides. Where is your evidence of any deformation, or your evidence of friction or heat, or all the things you're saying that was the problem? the spring's not going to melt. I mean, there really isn't any way to explain it. There can't be any possibility they have different energies. They have to have the same energy because the spring forces it to be the same energy both ways. Or the explosion, or whatever I use as a source of energy that produces energy in both directions. You know, I really shouldn't have to go over these things again. So again, we just don't, you would think if they're going to assert this as being a fact, that they'd have an experiment where they actually do, you know, this 10-ton train thing, okay, and they show us that the train going 5 miles, you know, the 5-ton train going 10 miles per hour, okay, produces more energy if I put a generator on the wheels than the, you know, 10-ton train going 5 velocity. Why don't they have a single experiment showing us this thing producing more effect in the universe, changing the universe more than this changes the universe? I mean, all this faster train can do is make deeper holes in things because it's got a higher velocity. When it hits something, it'll tend to move the stuff more in straighter lines, and the slower it's going, the more friction is going to spread the energy. But spreading energy and having energy are two, it doesn't matter how much I spread the energy. That doesn't say there wasn't energy. If I spread the heat, it doesn't change how much heat I disposed of. How much heat I gave something is going to change because of the direction. And that's all we're really saying here is yes, the heat will be in one direction when the when the faster thing hits something, the lighter, faster thing, the heat will stay in one direction, but it won't change how much heat there is. You have to know that. So there's no good history here. Leibniz was 50% off, again, 100% off you could say. I mean, again, he was predicting, it has 100 joules of energy, and the answer you're saying now is 50. So his answer was terrible. The argument he was making was pretty bad. It was pretty far off, right? So it really, he's saying, all the evidence proves it. It proves this. And it wasn't even close to the right answer, right? And the same thing for the French later, who decided to defend Leibniz's religion. It's still way off. They didn't fix this till the 1800s. And they never did any intervening experiments. So they just went with, Leibniz says so. He has no experimental evidence. He's just making he's making the theoretical argument. Well, the car travels 4 times as far, even though it's only twice as much time. And the constant force, the rain, back to the rain argument. You can't collect 4 times the rain because you're only in the rain twice as long. So anyway, so he's making theoretical arguments. So no evidence from Leibniz. The clay experiments are just, logically you can just know what clay, whose clay, what temperature clay, what mixture of clay. Again, you can just ask all these questions. What do you mean clay? Can I make clay do almost anything by changing what I made the clay out of? So of course you can. So clay can defend any theory. So that's a terrible experimental evidence. And then in the 1800s, they made a declaration that, we'll change the answer to 1/2. But we'll still provide you 0. I mean, just 0. 0 evidence for any of it. 0 experimental evidence of ever collecting anything called V² kinetic energy. More energy. 0 evidence of it taking 4 times as much gasoline to go 60 miles an hour as it takes to go 30 miles an hour. 0 evidence. Nothing. And this is the physics you trust. This is the physics you'll call people names if they don't believe it. Because your evidence is so overwhelming. Except it doesn't exist. Yeah. And then I can go into the other subjects, the whole relativity thing, Eddington never repeated. I mean, I've already made all these arguments. No counter argument, except a refusal to accept the truth. Okay, so yeah, people keep bringing up the amateur who did the experiment, in when we had the perfect eclipse over America, with a much inferior telescope and a CCD camera instead of high grade photographic slides. So no chance that it's a better experiment. So it's 100 years later. We have all of this advanced technology, and that we can't use any of it. 400 times better resolution from space. No one's explained why they haven't pointed just a regular camera. With 400 times better resolution, you see, you don't need a 12-foot telescope anymore, with a 12-inch lens. 400 times smaller will work. You could make it you could have 200 times inferior. That means you go from 12 foot to 2 inches, or something like that. And you still have 200 times better resolution with a 2-inch lens. So from space, a 2-inch lens still has 200 times better resolution. And your argument is that's the way science should be done. Science isn't about really producing evidence, it's just pretending you did it. Do the experiment weird in some back room somewhere and then just claim the truth. You don't have to prove any of this stuff. It's not part of the obligation is to compile a bunch of evidence. You just assert it and call anybody who disagrees with you an asshole. And be a pretentious, snotty douchebag. Because you can play with mathematical figures. But again, let's just understand. Feynman can play with math, but he, says things that are just, it's almost like it's baby talk. Kinetic energy doesn't have a directional vector. Momentum does, but kinetic energy doesn't. So even though it's made out of just mass and velocity, we're supposed to pretend that kinetic energy's velocity isn't in a direction. And momentum's velocity is in a direction. So when I use mv, it has a direction. When I use 1/2 mv squared, somehow it doesn't have a direction. The velocity lost its direction, just with, purely magical. Purely fraud. Purely nonsense. Obviously, that doesn't happen, but they need it to happen to fool you. They need to pretend there's some reason why it doesn't work the same way. No, of course it works exactly the same way. And your physics doesn't make any sense. You can draw it, you can explain it, you can point out. You never prove that this ton-ton train going half the speed doesn't have exactly the same amount of capacity to heat something, or to generate electricity, or to do any of the ways you would extract the energy as completely as possible. If you attempt to extract the energy as completely as possible, the 10-ton train will produce exactly the same amount of energy as the 5-ton train going twice as fast. So anyway, there won't be a rational reply. There won't be any concession. Well, yeah, Scary, you're right. This physics is sloppy. I still believe, but I'll concede this is sloppy. We shouldn't be telling you you're an idiot because you don't believe in our fantasies. That you don't believe that because we call it kinetic energy, it doesn't have a vector anymore. That the velocity somehow lost its vector. It doesn't know where it's going anymore because I called it kinetic energy. I mean, what? It's just such a crock of shit. Well, anyway, I don't need this here. I don't know why I do that. Funny things the brain does. I guess I'm just used to, you pull things into the middle when you're dealing with them. Anyway, so, all right, so I'll leave it at that. All I can do is attempt to reason with you. If you won't concede anything, you won't concede that you have weak evidence, you won't concede that somebody should have measured a stick of butter falling 1 meter, because it just seems perfectly logical. If that's going to be our unit of energy, how much does a stick of butter weigh when it falls 1 meter? Yeah, why don't we find out what that what that weighs, and then we can just say its weight instead of calling it a joule. We can just say it's a pound or a pound and a half or whatever. Yeah, that's all sensible. Why don't we do that? But you won't agree. We don't need to do that. We don't. Physics isn't about experiments. It's just about formulas. Formulas, and formulas that you defend with ludicrous ideas like, because I put a half in front of it, or because I squared the velocity, somehow it's not a vector anymore. Somehow it's not mass moving a velocity in a direction anymore. Even though, of course, it is. It's a train going down a track. You can't change the fact that it's a train going a specific direction. You can't get rid of that part. Shoot. Anyway. All right. Well, lost the voice thing. Age, I guess. It's just falling apart, little pieces at a time. Anyway, till the next time. I can almost feel my voice changing. I'm turning into an old fart. Yeah, right in front of that. On camera, I'm actually doing it. It's happening right in front of you all. Sucks. Anyway, till the next time and such. Yeah, I think that's enough. It is now. So, till the next time, such.